Hey everybody, we're going to start talking about real trigonometry today. And to do that, we need to start talking about the trig functions. Now there are 6 trig functions, but we're only going to focus on 3 for this particular class. Okay, the ones we're going to talk about are sine, cosine, and tangent. Now, in order to understand those 3 functions, we first need to understand this thing called theta. Okay, theta is this little mark. It looks like a circle with a line going straight across through it. So if you wanted to ever draw it, that's one way of drawing it. Okay, mine looks kind of like a pretzel almost. But what theta is, it's just a marker. Okay, we're just going to be putting that marker at a particular angle in a triangle so that we know which angle we're talking about, because we need to be able to reference that angle in order to figure out the different sides. Now, we have this thing called Sohcahtoa, which is telling us exactly what each of these functions do. Okay, so what we're going to do first is we're going to put down theta at one of our angles, and we're going to discuss the different types of sides we're going to get from theta. The first side that we're going to talk about is the hypotenuse. Now the hypotenuse is always going to be the longest side, and it's always the side that's across from the 90. Okay, our hypotenuse. It's very important that we are able to identify all these sides, but especially the hypotenuse. Okay, from theta, we have 2 more sides available. The first side that we're going to talk about is the adjacent side. Adjacent means it's directly next to the angle. The way that I think of it is it's the side that actually helps to make the angle, other than the hypotenuse. So we notice that here's the hypotenuse, the angle that we're talking about is right here, so the other side to make that angle would have to be the adjacent side. Okay, angle A, adjacent A, easy way to think of it. The final side is the opposite side. It's called the opposite side because it's opposite the angle, right? The angle is opening up towards this opposite side. And here's where we're going to start to see what this Sohcahtoa thing means. Okay, we're talking about from theta, sine is going to be equal to the opposite over the hypotenuse. That's what OH stands for, opposite over hypotenuse, and the S stands for sine. So from theta, we're talking about the opposite side and the hypotenuse. Another way that we can write this is sine of theta equals opposite over hypotenuse. That's the sine function. And that's how we're going to be using it for the most part in this class. The second option from theta is cosine. Cosine is adjacent over hypotenuse, or the adjacent value over the hypotenuse value. Okay, and again, from theta, we're talking about the adjacent side and the hypotenuse, and we can again rewrite this as cosine of theta equals adjacent over hypotenuse. And finally, we have tangent, which, as you can probably guess, tangent is opposite over adjacent. OA, opposite over adjacent. So we put theta at an angle, we label our opposite and adjacent sides. Those are the sides that we're referring to. And again, we can write down tangent of theta is equal to opposite over adjacent. Now, let's be perfectly clear. Okay, if we were to have a different angle, if we were talking about this other angle, okay, I'm going to put theta over here in a different color just so that we can see. Okay, now we're talking about green theta. Our hypotenuse is not going to change. Remember, hypotenuse is always across from the 90. However, from theta, we're going to notice that the adjacent and opposite side switch, because remember, adjacent helps to make the angle with hypotenuse. So this now becomes adjacent, and this now becomes opposite. Because remember now, this side is now opposite of our green theta. So in each of these examples, sine is still going to be opposite over hypotenuse. However, now our theta would be down here, our opposite side would move over to here. Cosine is still a over h. However, because we're going from over here, our adjacent side moves, our hypotenuse stays. And lastly, tangent, if we move our theta over here, opposite and adjacent switch. So our numbers would be in different spots. Okay, this is going to make a lot more sense when we start looking at problems. Just keep in mind that sine is always opposite over hypotenuse, cosine is always adjacent over hypotenuse, and tangent is always opposite over adjacent. If you can remember this right here, then you're going to be doing fine with this, because we're always going to reference our angle or our sides from theta, from the angle that they give us. So let's take a look at a couple of practice problems. Now we're going to need calculators in order to do this. There are ways of using charts. We're not going to be doing the charts in our class. We're going to be using the calculators. One thing I'm going to warn you is you must make sure that your calculator is set to degree mode for these problems. If you check, your calculator is going to have two options, radians and degrees. We want them in degrees because our answers we're hoping to be in degrees. Okay, radians have a lot to do with trigonometry. We're not going to be working with them in our class for the time being. Okay. The other thing is that I don't have a calculator here with me, so I'm going to have to be doing my math on the Google calculator, which I can't show on the screen, but that's not a big deal. I'm going to just assume that you guys type it into the calculator correctly, and then we'll go from there. Alright, so here's our first example. This problem asks us to find sine, cosine, and tangent of theta. And as you notice, our triangle already has theta placed. Okay, so from theta, I want to start marking off the sides. So I'm always going to do it the same way. I'm always going to mark my hypotenuse first. It's always across from the 90. That one never changes. Then I'm going to always do my adjacent side. Why? Because it's easier for me to remember that adjacent makes the angle. So I now know my adjacent and my hypotenuse, which leaves the third side as opposite. Now I've got everything labeled. The next thing I'm going to do, and I do this even still, I always write down Sohcahtoa. It's going to be somewhere on my paper. I know I have it already written above, but I want it to be in my sight. Okay, why am I doing this? Because I want to remember that sine is opposite over hypotenuse. So for this problem, sine of theta, which is opposite over hypotenuse, we now can just look at the values and replace the values into our problem. So sine of theta is 15 over 17. Okay, because all I did was just replace O and H with 15 and 17. Cosine from theta, same idea. We already know that cosine is adjacent over hypotenuse. And all I have to do is replace the values of A, which is 8, and hypotenuse, which is 17. So 8 over 17. And lastly, we have tangent. Tan of an angle is opposite over adjacent. So we're talking about tangent is equal to opposite, which is 15, over adjacent, which is 8. Okay, so again, we're always referencing from theta. Let's go to a slightly different problem. Okay, here we have sine of A, sine of B, cosine of A, and tangent of B. Okay, so what we're going to do here is we're going to have to put some different markings down. Let's just work with the ones that say from A, sine of A and cosine of A. So what I'm going to do first is I'm going to put theta down at A, and I'm going to mark all my sides. Again, my hypotenuse is my longest side. Here, my adjacent side, making the angle, is over here at 24, which means our last side is the opposite. Now, sine from A, it's still going to be opposite over hypotenuse. That's what SOH stands for. So from theta, we have 10 over 26. So sine of A equals 10 over 26. Cosine of A is still A over H. That's what cosine stands for, A over H. So we just need to replace those values. Cosine of A equals, here it's 24 over 26. Now let's switch gears. They ask for sine of B and tangent of B. That's fine. I'm just going to move my theta. Okay, so it's no longer here. I'm going to get rid of my adjacent and my opposite. My hypotenuse still stays the hypotenuse. But now I got to think. The angle is being formed right here. That means my adjacent side now is 10, leaving my opposite side as 24. So notice they all switched. Okay, so now we're going to do sine of B. Sine is still opposite over hypotenuse, right? Sohcahtoa never changes. It's still opposite over hypotenuse. The only thing that's changed now is my opposite value. So here, sine of B is equal to 24 over 26. And lastly, they ask for tan. Tangent of B, still O over A, tan, toa, T-O-A, okay? So we want to replace the values. 24 over 10. Alright, so I have a couple of problems that you can try on your own. As you can see, this problem right here is asking for all 6. Sine, cosine, tangent of A, sine, cosine, tangent of C. So give it a minute for yourselves to try this out. Do all of the cosine, sine, and tangent of one angle first, and then switch and find the other angles afterwards. Pause the video and resume to see what the answers look like. Alright, let's see how you did. So I'm going to do sine, cosine, tangent of A in red. Sine, cosine, tangent. Now, from A, I'm going to mark theta. And I'm going to mark my hypotenuse, my adjacent, and my opposite. Now we're talking about sine of angle A. So that would be opposite over hypotenuse. So 45 over 53. Cosine of A, we're talking about adjacent over hypotenuse. So 28 over 53. Tangent of A is opposite over adjacent. So we want 45 over 28. Now we're going to switch colors. I'm going to move theta to C because that's what they're asking for. My hypotenuse stays the same, but now my opposite and adjacent switch. Remember, adjacent is helping to make the angle. So when I do sine of C, I'm looking at 28 over 53. Cosine of C, I'm looking at 45 over 53. And tangent of C, I'm looking at 28 over 45. Hopefully you came up with those same solutions. If there was ever a situation for you to reduce, then make sure you reduce the fractions as much as you can. Now, one last thing I'm going to point out about this is this quick little bit of information. Notice that sine of A and cosine of C have the same solutions. Okay? And again, we notice that cosine of A and sine of C have the same solutions. That should make sense because all we did was switch the side association with the values, so it should make sense. What that means is that the sine and cosine of complementary angles, those that add up to 90, are going to have the same solution. And if you notice with tangent of A and tangent of C, our values just switched, right? They flipped. Again, that should make sense because it's O over A, and if we switch O and A, then it makes sense that they should be flipping upside down. Okay, so an easy way sometimes, if you can get sine, cosine, and tangent of just one side, you know that the cosine is going to be the same as sine, sine is going to be the same as cosine, and tangent is just going to flip. Okay, so a nice, easy, fast way of doing these problems. So here's one last problem for you to try out. Take a second, try it out, pause, resume when you're ready. Alright, let's check out how you did. So we're going to do sine of r first. So I'm going to put theta at r. Now sine, as we remember, is O over h. So here's h, here's a, here's O. Sine of r is O over h. That's my solution, 11 over 61. Tangent of q, well, let's put theta at q. Hypotenuse stays. These are going to switch. Remember, that's my adjacent side. This is now my opposite. Tangent is O over A, so O here is 60. A is 11, and these are my solutions, 60 over 11. Hopefully you got that one correct as well. Now in the next video, we're going to start talking a little bit more about trig, where we're going to need the calculators. So I do apologize for mentioning the calculators a little bit early. We're still going to need them for trig coming up. These particular problems, there's no necessity for us to plug in. That's all we're looking for, is to just get used to defining our sides and then putting them into the correct functions. Alright, if you guys have any questions, you can either leave them on the website or you can bring them into class. I'd be glad to answer them.